So last week, I apologise for my absence, but I couldn't do much about it. Last week, we focused on expanding and techniques for expansions. We had a look at perfect square expansions. We looked at difference of two square expansions, and when you've got two binomial factors and expanding those, and a 2 by 3 expansion as well. So that was expansions week, but it's not really the main focus of the course. The focus of this algebra techniques is to look at factorising, which you probably have done some of in Year 9 maths already. So do tell me if I'm going too slow or choosing things that you've covered before. But you can see the success criteria for today are as follows. I can recognise what technique to use when factorising. So that's going to be one of the things I want you to be able to walk away with. I mean, it's an ongoing journey, really. But I think the key to being able to use these algebraic techniques, these tools out of your toolbox, as I've mentioned in previous lessons, is the capacity to go, oh, that's that kind of problem, and therefore it needs that kind of tool. I.e., don't get your hammer out every time you need to get to screw in, for example. So we're going to focus on being able to recognise them, even if we don't know how to apply the tool yet. But I am going to give you one tool, which is factorised by grouping. Have you done factorised by grouping in regular maths? Doesn't sound familiar, so probably not. Yeah, okay, cool. That doesn't surprise me. I think that's about right. Before we have a look at factorising, though, I'm going to give you just these two problems here to start with. I'm going to give you, because we did expansions last week, I'm going to pause the video and I'm going to give you 2 minutes to do both of those two problems. That's 1 minute per problem. On your marks, get set, go. Now, you should have been able to do those in 1 minute, not 2 minutes. And the reason why is because you need to be able to identify patterns and apply the patterns effectively for a shortcut. So some of you got the right answer, but it's kind of like saying if you wanted to drive to Launceston, the first thing you do is go via Queenstown, right? Could you get to Launceston if you went via Queenstown? Of course you could. Would that be the most efficient route to get to Launceston? No. Scenic, the lovely devastated plains of Queenstown, followed by Strawn, beautiful coastal town, up the west coast, lovely, cross from Burnie over to, lovely trip, but nevertheless not very efficient way of getting to Launceston. Okay. Similarly here, I saw most people, so just so you know you're not alone, multiplying it out either using the box method or going 3 times 3, 3 times 2y, minus 2y times 3, minus 2y times 2y. But this is a special kind of expansion, right? What is it? Someone can call it out. 3 people in this room can call it out. Difference of 2 squares. So there was absolutely no need to do any sort of box method or anything. And can I say, for 9 Maths Extended, can I say that I would expect you to shortcut? Some conscientious students feel like, well, they need to show as much working out as they possibly can to demonstrate how good they are. But in this instance, it doesn't. Because in this instance, it demonstrates that you're not there yet with seeing the pattern. And the pattern is, we've got a number here, 3, that also appears here. We've got a term here, 2y, that also appears here, 2y. We've got a minus here, and we've got a plus here, which means that the answer is just square the first one, which is 9, minus difference of square the second one. So there you go. There's 10 seconds work. Okay? Efficiency is the key. As a 9 Maths Extended student, you need to not continue to lean into the long way about of doing things. Okay? Will you get the right answer if you continue with box method? Of course. But see the box method for these problems as like going to Queenstown. It gets you there, but really not efficient. The second one here, it's already in the right format for you. This is a what kind of problem? Perfect square. Thank you, Sam. So what do? We square the first term, so that's 9. We multiply those two terms together. 3 2s are 6, y, and then double it to get 12y. Because there's a subtraction here, then it needs to be a subtraction here, and square the second term, always added on. So it's 2 squared is 4 and y squared. So it's 9 minus 12y plus 4y squared. Are you with me on this? It's just practice until you get it. You'll click. But I cannot emphasize enough. There's probably students around here in this class thinking, yeah, but it's a lot faster if I do the box method because I'm familiar with it. You know? That may be so, but once you are familiar with perfect squares and dots, this way will always be faster. In other words, if I put two people side by side, one person doing box method who's an absolute gun on box method or chicken beak, and one person who's an absolute gun on difference of two squares and perfect squares, this person will always win. For the video, I'm just pointing to this person who's done perfect squares and dots. They'll always win, right? Because they'll efficiently move through the problems. This other person will get there, but not efficiently. They'll lose a race, effectively. Here's one more problem for you to try. I'll leave it all zoomed out now so you can see it. For this one, there is no trick. Just expand it. Here we go with the solution just to confirm it. And I'll do it like I said, I'll just do it by observation, which simply means I'm just looking at it and doing it in my head, but I'll use my little pointer to be my eyes. So I multiply 2x by 3x and I get 6x squared. And then in my head I'm going, well, now I need my x term, right? So I've got 2x times 4 is 8x, 1 times 3x is 3x. So in my head I'm going 8x plus 3x is 11x. Is that okay? Just doing it by observation rather than writing it all out. And then the last thing I'd go then is just for the number 1 times 4, which is plus 4. So 6x squared plus 11x plus 4. You okay with that? Any questions, dramas? Okay, so observation's fine for this. If you chicken baked it or box methoded it, that's absolutely legit as well. And it's not a bad visual way of making sure, I will occasionally make a mistake because I haven't looked at it properly. So doing it by box method or chicken bake does spell it out reasonably as well. Okay, so here's a little bit I want you to do in your summary books, please. Maybe I'll just get you to focus on this first page. We're going to use, I like to make a connection between the words and what we're doing. Heading in your summary book, please, called Factorising. And I am really conscious of the fact that students frequently find mathematics magical because of the language we use, like terms and common terms and, like terms and factorising and expanding. And if you can make sense of the words and what they really mean, it's a really important step because everything you do has language attached, a special language attached to it. So if you're a surfer or a skater or something like that, you know that there's a language involved with those kinds of things that are only pertinent to that sport, that aren't used anywhere else. When you start using it in front of someone who doesn't skate or doesn't surf, then they get a bit of a glazed look over their eyes so they don't know what you're talking about. And it can be the same thing in maths. So in this instance, we need to make sure it's really concrete what we mean by these words so that we can use them. And also, the other thing I just wanted to point out is that although a lot of these words are based on algebraic stuff, they apply to all numbers, which is why I'm starting off with a number example. So I've got here factorising is writing an expression as a product of factors. Now, product is one of those words that represents one of the four operations, the result of, really. Which one does product represent? Multiplying. Yep. So if you need to, in a little cloud bubble somewhere, put product equals times up here like that, in case you forget. So difference of two squares is subtraction. Product is multiplication. Sum is addition. Quotient is division. Okay, so get used to the words. That's part of the rich language which helps us explain things in fewer words once we know what the words mean. So, writing an expression as a product of factors. I'll give you one. I want you to write down two more. So 12 is equal to 12 times 1. The two factors are 12 and 1. When we multiply them together, we get 12. Write down 2 more examples. Okay, who wants to call out one of their examples? No one. Man, come on, guys. Or 2 times 6? Or 3 times 4? Have I missed any? Two times 3? That works too, does it? So it doesn't have to be just 2 factors. It's a product of any number of factors. At least write down 2 times 2 times 3 if you haven't already. Just to reinforce in your head there that 2 times 2 times 3 is equal to 12. It can be more than, and times 1 as well. It could be 4 factors. So there's no limit to the number of factors. Oh, and why not this as well? It's not a normal one, right? You don't normally say a half is a factor of 12, but technically speaking, it is the product of 2 numbers, a half and 24. So there's so many examples we could put in there, but there's just a few there. Similarly, on the right-hand side there, so for slide 6, those 2 things there are also factors of, can be written as factors. Remember, a factor is just an expression. I'll say that again. Factorising simply means turning an expression, whether it's a number like 12 or something like 9 minus 4y squared, and turning it into a multiplication of things called factors. So I'll give you a moment to see whether you can fill out these 2 examples here, but don't feel bad if you can't. But as a hint, I'll just do this, and then I'll put it back. See if you can do the write 9 minus 4y squared as a product of factors, and then do the same thing with 9 minus 12y plus 4y squared, and the same thing with 6x squared plus 11x plus 4. Give you a moment. Don't feel bad if you can't, though. So 9 minus 4y squared is in fact the same as the answer here. Yeah? So if I go backwards, I can write 9 minus 4y squared. I might just change colour. So no, I won't change colour. As 3 minus 2y multiplied by 3 plus 2y. Does that make sense? So there's a few things that in algebra, I guess it's particular to algebra, and that is implied. There are 2 things that, there's probably more than that, but in this instance, the multiplication, remember, in algebra is implied. In numbers, I can't imply the multiplication operation. Imply means I don't write it in, but it's understood to be there. So if I go that, what have I written? Top there. 32, right? I definitely have not written 3 times 2. That's because I need the multiplication symbol so I can tell the difference. But if I write 3a, that means 3 times a, right? I don't need the multiplication symbol. I just know that it's going to be 3 lots of a. Yeah. A question? Yeah. Do you mind if I come and see you in just a sec? Yeah, cool. I won't be long. So just be mindful of that if you don't see an operation between 2 things in algebra, it's because it's multiplication. Similarly, if you don't see an actual physical number in front of a variable, it's implied to be one lot of it. Okay, so that's 3 minus 2y, 3 plus 2y. 9 minus 12y plus 4y squared is simply a perfect square. Look at example 2 there. 9 minus 12y plus 4y squared. So I didn't expect you to be able to factorise it, but you had the answer already. So it wasn't quite as mean as you thought. So 3 minus 2y all squared. Now, that looks like only one factor, right? But it's a repeated factor. It's 3 minus 2y times by 3 minus 2y. Just like 2 times 2 is a repeated factor of 2 when we're doing factors of 12. So it's a repeated factor. I could have written that as 2 squared times 3. We okay with that? I'm rushing because you're not giving me any feedback that I'm going too fast. So if I'm still going too slow, I apologise. If I'm just right, all good. But if I'm going too fast, you need to ask questions. That slows me down. Does anyone have any questions? And question could be something like, you did what now? Hey? How? What? How does that work? That's fine as well. Okay, the last one, 6x squared plus 11x plus 4. Well, if I flick back here, it's 2x plus 1 times 3x plus 4. So I'm going to write that in. Oops, so daisy, try that again. 2x plus 1, 3x plus 4. Like so. 2x plus 1 times 3x plus 3x plus 4. Now, what we're going to learn in this part of the unit, excuse me, and what you already possibly have skills in already, again, I apologise, I'm not too sure what happens in regular maths, is how to do those sorts of things. How do I recognise the difference of two squares? Well, and then how do I solve it? In this lesson, I'm going to try and get you to recognise perfect squares. And what do we need for a difference of two squares? Well, we just need something which can be written as a square, like 3 squared, minus, because it's a difference, of something else that can be squared. This is 2y squared, right? So as long as it's square minus square, then it will fit this pattern and we can do it. This one here, I've got a square number because 9 is 3 squared. I've got a square number because 4y squared is 2y all squared. And if I multiply them together, I get 3 2s are 6y. And double it, I get 12y. So this tells me that this fits the pattern of a perfect square. And therefore I can factorise it without doing anything more difficult. This one here is more tricky. It's definitely not a difference of 2 squares because although that's a square and that's a square, that's not. And there's 3 terms. So it doesn't fit difference of 2 squares. It's not a perfect square because even though that's a square, that's certainly not, 6 is not a square number. So it's not a perfect square. And so we have to do other factorisation called trinomial factorisation. Okay, and we'll go through that in more detail. And I'm going to show you a special method for working out non-monic trinomials, which is when you've got a number in front of the x squared other than 1. So we'll look at non-monic factorisation. But as a general summary, what is factorising the opposite of? Starts with x, expanding. So factorising is the opposite of expanding. Okay. Next step, we're going to do a few strategies. It won't take too long, but I'll just pause. Have a talk amongst yourself for a second. These steps are really important and should be in your summary books. So I'll try and give a really basic example of each. So there are so many tools to fill up your toolbox with, but we don't go through too many of them in year 9, so it's not too traumatic. But nevertheless, it is important that you get used to trying to apply these rules in the order that I've given. Now, you won't always be able to apply these rules because it won't fit the pattern, but you should always check to see first. And the first thing, always, is you should look for the HCF, highest common factor, right? Sam? Okay? So highest common factor. So an example of that is 3x plus 12. That would be 3 outside of x plus 4. I'm assuming you know how to do that, but I'm just giving you a basic illustration of what I mean by HCF. So take out the common factor of 3, and you're left with x plus 4 on the inside of the brackets. Be okay with that? Right, so that's fun. The important thing is that as you learn bigger and bigger tools, sometimes you will go straight to the big tool. Like you might see a non-monic factorisation, right? I'll try and give you an example actually, just so I want to illustrate what I mean. So I'm just going to do it in blue here. I'm going to rub it out, so don't bother writing it down. But I might have 3x squared plus 12x plus 9. And your instinct, once you've learnt the skills, I know you haven't quite got it there yet, your instinct might be, well, this is a trinomial because there are 3 terms. There's a squared term, an x term, and a constant number. So that fits the pattern of a trinomial. It's not a perfect square or a dot. So what I think I'll do is I'll do what's called a non-monic factorization. And you can do it. You will get there if you do it. But you've missed a really simple first step. What's that? Yeah, you've got to Hookeff. You absolutely have to Hookeff first. So here's the Hookeff step. Hookeff, highest common factor. It did sound like I had a hiccup. I hiccuped, but I didn't. So if I go that, I've got x squared plus 4x plus 3. And that's a much easier factorization to do inside the bracket. I'm not done. It's not like Hookeff it and done. You Hookeff it, then look inside the bracket. Yes, everyone here in this class, it's a safe space. Everyone is welcome to Hookeff it whenever they want to. So once you've Hookeff it, if you can Hookeff it, then you look at the brackets and say, is there anything else I can do? And maybe there's another Hookeff to do. But if there isn't, you can go, oh, well, I can do that. That's a simple monic trinomial now. And I can see that's x plus 3 multiplied by x plus 1. Don't worry if you can't see that. That's not the point. The point is, by applying the Hookeff first, you've then got a simpler problem which can be solved a lot more simply. Okay? So that's why I'm saying do it in this order. But don't stop. So the first one is Hookeff. The second one is dots or perfect square. Does it fit the pattern? It'll only be one or the other. If it looks like dots, it won't be perfect square. If it looks like perfect square, it won't be dots. So you should check to see whether it fits that pattern. E.g., have I got enough room for 2 examples here? Again, really simple examples. 16 minus y squared is 4 squared, so 4 minus y, 4 plus y. And to recognize the difference of 2 squares, it's really simple, right? If it's got more than 2 terms, it's not a dots. Can't be. You need only 2 terms to be dots. If it's more than 2, it's on your laptop now. If it's more than 2, then dots is not going to apply unless you have to do something else, which is possible. And then you just need to check whether there's a square on the left of the minus sign and a square on the right-hand side. Okay, that's how you do dots, right? So if it was 16 plus y squared, it's not dots because it's not a difference of 2 squares. If it was 15 minus y squared, it's not dots because it's not a difference of 2 squares. If it's 16 minus y squared minus x squared, it's not dots because it's a difference of 2 squares. See what I mean? I'm hitting the notes each time. So it has to be a minus, has to have 2 terms, has to be squared terms, or terms that you can square. Difference of 2 squares. Or say 16 minus, I'll go plus 8y plus y squared is equal to, doesn't matter if you can't see this yet, 4 plus y all squared. So again, looking at the pattern, you're saying, is one of the numbers a square number? Yeah, 16, it's 4 squared. Is the other number a square number? Yeah, it's y squared. What happens if I mush 4 and y together? What do I get? 4y. What happens if I double it? 8y. Do I have 8y? Yeah, I do. So I've got 3 terms. 2 of them are squares. And the third one is, if I mush them together and double it, I get it. So that's what you need to recognize. You know, it might not always be written in that order. If I wrote 16 plus y squared plus 8y, that is still a perfect square. Yeah? But if I had 16 plus 8y minus y squared, it doesn't fit the pattern. If I have 16 minus 8y plus y squared, that doesn't fit the pattern. It will be 4 minus y all squared. So what you need to do, what you need to exert effort over is recognizing the patterns. Because once you have broken the back of that, yep, 9 times out of 10, I can see that it's a particular pattern, then the rest of it becomes more straightforward to you. If you continue to spend time utilizing less efficient tools, then doing more complex maths becomes even more difficult for you. Okay, so you've got to build up automaticity. Okay, What's the third one then? The third one is monic is monic, non-monic trinomials. I'm going, oh, okay, because there's actually not a fourth one here. Okay, now a trinomial, tricycle, trifecta. What does tri mean? Triangle. 3. Okay, nomial gives a sense of number, does it not? Nomial, yeah. Okay, so trinomial is a 3-termed expression. A monic trinomial means, and we're going to do this properly. This is the summary, so we'll do it properly later. A monic trinomial is where the leading term, the x squared term, has a coefficient of 1, which is implied, so you don't see it. A non-monic doesn't. It has a coefficient of something else. So I'll do 2 examples here. And again, you don't have to know how to do this. X squared plus 5x plus 6 can be factorised into x plus 3 times x plus 2. That's a monic because the coefficient of x squared is 1, right? We don't write it in because it's implied. It's an invisi one. The other one I'm going to steal. I'm going to flick it. Oh, hang on, I'll just freeze it. Then you can keep on writing. What was it? 6x squared plus 11x plus 4. (6x squared plus 11x plus 4) is non-monic because the value in front of the x, so the coefficient of x squared is 6, so it's not 1, so it's not non-monic, and that would factorise to, should know, 2x plus 1, 3x plus 4. There we go. So they're examples of non-monics. And step 4 there is other methods. Actually, you know what? I'll make it, sorry if you've already written it, but we will put a 4th one in. And that'll be number 5. So 4 will be grouping. And I'll do a really simple example of grouping in a second. And you won't understand it until I go through it properly. And step 5 is other methods. In other words, as you progress through your maths career, you will learn more and more and more methods so that your toolkit gets bigger and bigger and bigger and bigger, so that when you get something like x cubed minus 8, you're able to go x cubed minus 8, well, that's clearly x minus 2 outside of x squared plus 2x plus 4, close bracket. And then pen drop, you're done. Okay? But you don't do that until maths methods. So if you do maths extended next year, you'll do it in maths extended next year, or you're doing grade 11 maths methods if you wait till then. Grouping, I'll just give a really simple example. I didn't actually prepare this one, so I hope I can fit it in. AX plus A plus BX plus B. Oh man, that shouldn't be an equal sign. Notice already there's more than 2 terms there. Equals A outside of x plus 1. Can you see what I did there? First 2 terms, took a common factor of A out, plus B outside of x plus 1. And this is the bit which I'll explain more in a second, which equals A plus B, x plus 1. I'll explain later, but just write it down for the time being. But you can see I've gone from 4 terms in this instance, and grouping almost always is 4 terms. Sometimes you have to make the 4 terms, but it's almost always 4 terms. And then I've taken out a common factor of A. So I've got a partial factorisation here and a partial factorisation here, but the expression hasn't been factorised yet because I basically split it into 2 bits, this plus this. But when I take out a common factor of x plus 1, I've now got a plus b times x plus 1 that is now factorised because it's a product of two factors. It's not always two factors, but for the majority of the stuff we do this year, it'll be 2 or 3 factors only. Okay, before I move on, does anyone have any questions? Sorry that this is so theory heavy, but it's really setting us up for work that we can do later on in the week or on Thursday. Okay, quick example into your theory books. I've got this example because I wanted to show you that you don't just stop at one step. So 3x squared minus 12, what exactly should I do first of all of those 4 steps? Highest common factor, right? We always start with highest common factor and see whether it fits. Is there a highest common factor? Yeah, there is. It's 3. So I take out 3 and I'm left with x squared because 3 times x squared is 3x squared and 3 times 4 is 12. So I've got 3 outside of x squared minus 4. But we don't do the pen drop yet because then we look inside the bracket and believe it or not, we follow those 4 steps again because we might have accidentally not taken out the highest common factor. I mean, it's pretty obvious for this one, but sometimes you can take out 2 when you should have taken out 4 or something like that. So you just double check. Are there any common factors left? Nah, nothing except 1 between x squared and 4, so that's a bit boring. So number 2, is it a dots or a perfect square? Well, it sure ain't a perfect square because there's only 2 terms. Is there a difference? Yeah. Is x squared a square number? Yeah, it's x squared. Is 4 a square number? Yeah, it's 2 squared. So I've basically got, which you can do in your head, x squared minus 2 squared. And so I can go, that equals 3, x minus 2, x plus 2. Yeah? We'll practice these specifically in another lesson, but more or less, that's what we're talking about. Okay. Factorise by grouping. This is what I wanted to show you. So with factorise by grouping, we normally have 4 terms, and what we do is we pair 2 of the terms together. Now, they might not always be right next to each other, but in this example, they are. And you take out a common factor, or the highest common factor of that pair. So if I look at x squared minus 2x, which I'll just underline in blue, x cubed, sorry, minus 2x squared, what's the highest common factor there? Anything else? X squared's better, isn't it? Because x squared will go into x cubed. X squared times x is x cubed, yeah? So we've got a common factor of x squared, and we're left with x for the first term minus, and then we've got 2 for the second term. Now, on the next one, which I'll do in red, so it stands out nicely, what's our common factor there? Yeah, that wasn't too bad, that one, was it? But when I do that, can you see how now we have effectively a repeated, what colour, I'll use that one, a repeated factor here and here. X minus 2 appears twice. So it's x squared lots of x minus 2 and 4 lots of x minus 2. Does that make sense so far? Okay, the reason why that's important is because that makes it a common factor for both of those parts. So x minus 2 is a common factor, is a factor of this bit, and x minus 2 is a factor of this bit. So it's a common factor. Yeah? It's a common factor. Just because it's x minus 2 doesn't mean it behaves any differently to any other number. You know, whether it's 3 or 7 or x or 4, it's just a common factor. And we know what to do with common factors, right? We take it outside the bracket. So I'll take x minus 2 outside the bracket here, but I need to put brackets around it to keep it together. And then what am I left with? I'm left with x squared plus 4. So I'm left with the bit outside the bracket here and the bit outside the bracket here, including the operation. So I've got x minus 2 as the common factor and x squared plus 4. What do you reckon? Okay, I've talked you to death. I think I want you to just very quickly try that. I'm going to give you 2 minutes to try that. We'll have a look at it, and then I've got a problem sheet for you to do. So, to solve this, I'll just zoom up so we can see it nicely, I suppose. Again, no tricks here. It's just the first 2 terms and the second 2 terms. But there is a little trick, actually. So the first one has a common factor of y, yeah? So if I take out a common factor of y, I'm left with x minus 5. Keep your eye on that, because what I want to do, if it is solvable by grouping, and of course it is because it's an example, I need an x minus 5 for my next pair, right? So I put my minus 2 here, and I've got x because minus 2 times x is minus 2x. But minus 2 times minus 5 will give me positive 10, which is why it does work out with a minus 5 there. So now I've got my repeat of x minus 5, and so my solution is take out the common factor, x minus 5, and y minus 2. Yeah? It can get a little bit more tricky. There can be instances where you've got to take out a common factor of 1 and stuff like that. So there are a few tricks, but I won't waste any more of it. Well, not waste. I won't spend any more time on it now. What I've just handed out, and I will attach it to Google Classroom for those watching from home, is a puzzle sheet. Now, the puzzle sheet is double-sided. I want you to go to the sideways sheet, which is how did Snidely Spellbinder write a 4-letter word that begins and ends with E? So it's 2-sided. Make sure you're on the side that says Snidely Spellbinder. It's sideways like this. This puzzle sheet is full of grouping terms. So I'm getting you to practice grouping, the grouping method. We've got about 3 minutes left in this lesson, plus you've got homework time between now and Thursday to complete just this side. Don't do the other side because it's actually got a lot more complicated problems and not all of them are grouping. But finish this side, and there will be, I'm sure, issues with individual problems here that you're not too sure about. But I'll come around and help individuals for the next few minutes, and then send me an email if you need help finishing your homework. Get into it.